Hello class, in this video I'll be showing you an application of average rate of change and instantaneous rate of change. Let's begin. The revenue in thousands of dollars from producing X thousand units of an item is R of X is equal to 10X minus 0.002X squared. Find the average rate of change of revenue when production is increased from 1,000 to 2,000. Since the problem is asking for an average rate of change, we will need to apply the average rate of change formula. However, we need to be careful because in the problem it states X thousand units. So we need to rewrite 1,000 and 2,000. So 1,000 can be rewritten using the number 1 and the word thousand. This implies that X is equal to 1. Similarly, 2,000 can be rewritten using the number 2 and the word thousand, which implies that X is equal to 2. Now we can apply the average rate of change formula. We will have R of 2 minus R of 1 divided by 2 minus 1. You can use Decimus to find the values of R of 2 and R of 1. So we will have 19.992 minus 9.998 divided by 1, which is equal to 9.994. Now we need to label this answer. The numerator will be thousands of dollars, so we'll have 9.994 thousand, and the denominator will be 1,000 units. So the average rate of change is $9.994 thousand per 1,000 units. Now to interpret this result. If production of the item increases from 1,000 to 2,000, revenue will increase by exactly $9.994 thousand. Now it's perfectly fine to write 9,994. The reason why we use the word exactly is because we are looking for an average rate of change, and the span of the interval is exactly 1. Now on to part C. Find the instantaneous rate of change of revenue with respect to the number of items produced when 1,000 units are produced, and interpret the results. In this example, we're looking for an instantaneous rate of change, so we are going to apply the instantaneous rate of change formula. And that will be the limit as h approaches 0 of r of a plus h minus r of a, all divided by h. And we're going to evaluate this expression when a is equal to 1. So we'll have the limit as h approaches 0 of r of 1 plus h minus r of 1, all divided by h. And to the side, I'm going to evaluate r of 1 plus h. So r of 1 plus h means that wherever you see an x in the function, we're going to substitute 1 plus h. So this will be 10 times the quantity 1 plus h minus 0.002 times the quantity 1 plus h squared. Distributing the 10, we have 10 plus 10h minus 0.002. Now, if we expand 1 plus h all squared, that will be 1 plus 2h plus h squared. Distributing the negative 0.002 and combining like terms, we will get 9.998 plus 9.996h minus 0.002h squared. We've already evaluated r of 1 in part A, and we got 9.998. Now I'm going to make all of the necessary substitutions. After making the substitutions, you'll notice that the 9.998's zero out, and I'm going to factor an h out of the remaining two terms. Now you'll notice that there's a common factor of h in the numerator and denominator, so I will divide those out. And what we're left with is the limit as h approaches 0 of 9.996 minus 0.002h. And this will equal 9.996. And we're going to label this number exactly the same way we labeled the answer in part A. So this will be $9.996 thousand per 1,000 units. Now to interpret this number. If production of the item increases from 1,000 to 2,000, revenue will increase by approximately $9.996 thousand. And again, it's perfectly acceptable to write 9,996. So I want you to notice a couple things. Notice that we didn't go from 1,000 to 1,001. And that is because 1,000 is actually x is equal to 1, and 2,000 is x is equal to 2. So the span of this interval is actually 1. The other thing I would like you to notice is that we use the word approximately. We use the word approximately in this interpretation because we are trying to find an instantaneous rate of change. And when we have an instantaneous rate of change, we're only given 1 point. And when we're given 1 point, we can only find the approximate change in the function when we add 1 unit to the given point. And we are done.